What is Canvas? First, it's an HTML element for creating graphics. It is also a container, and with the help of scripts, you can use this place for drawing, animation, games, data visualization, photo manipulation, and real-time video processing. To work with Canvas, you need to place the appropriate tag in the body of the HTML document. Has anything changed in the browser? Let's use the element inspector. Canvas is in place, just invisible for now. Pay attention to the default sizes. We have the ability to set an identifier for a new element, and later use it, say to change the style or access the element through a script. Let's use CSS styles and set the canvas element to a black background. Using the width and height attributes is one way to set the dimensions of the canvas. The default units are pixels. You can also use percentages. But we will set the dimensions in a different way. More on that later. We need zero padding. Let's also create a warning that will appear if the browser does not support Canvas. And we will indicate this link to an external file with a script where we will build something very interesting today. So, in our first project, there should be two files, HTML, we have already finished with it, and JavaScript, which we are starting to work on. We will be using strict mode, and this will help us write secure JavaScript. Let's create an object named C, short for creative, and fill it with properties and methods that will perform the animation of our first project. So we need two properties, canvas and CTX, short for context. Let's create an initialization method. To work, you first need to extract the node in the DOM. That represents the previously created canvas element in HTML. We will do this with the getElementById method. An alternative will be the querySelector method, which returns the first element of the document that matches the selector specified as a parameter. Let's set the dimensions. We want to get full screen mode. We can now access the draw context using the getContext method. Here are the possible context types. We used the very first, 2D. Let's see what this context is. To do this, we call the initialization. Here is an object with a large number of properties and methods. We will study them in this course, but for now let's try something simple. For example, the fillRect method. It draws a filled rectangle. The first two arguments are the coordinates of the upper left corner. Next is the width and height. Nothing appeared because the default fill color is black, and we need to override it to see the shape on our black background. Similarly, you can work with the stroke. Let's try the interactive features. Anchor the shape to the cursor position. Let's use the addEventListener method to register mouse movement on our canvas. As the coordinates of the upper left corner of the rectangle, set the coordinates of the cursor. These properties contain the horizontal and vertical coordinates relative to the entire document. For correct work inside the event handler, you must use the name of the object to access its properties. Note that Canvas retains all drawn rectangles. I would like to erase previous states. The simplest is to fill the entire canvas with black using the fill rect method you already know. Let's define the fill color using the HSLA system. The order of the arguments corresponds to the abbreviation hue, saturation, lightness, and alpha channel. We'll be working a lot with colors in this course, and we'll cover color schemes in more detail later. These numbers correspond to black, a completely opaque color. The previous states are erased. It looks like we are moving the same rectangle. Let's try to reduce the transparency value a lot. Fade effect provided with an alpha channel when filling the canvas. This is just one option for cleaning the canvas. Take a look at the other methods available. In this course, we will try them all. Let's continue our acquaintance with canvas and ways to animate it. And always keep in mind the beautiful code. To build animations, we need calculations. In the case of interactive animations, the initial data for calculations can be the cursor coordinates. We will use these properties inside the event handler when the mouse moves. Let's create separate properties, the number of objects for animation, and an array of colors. Now the second method of our object. The method is very simple, and it will need to build an array of colors. With amt equals 10, this will be 10 colors from the color wheel. The construction is done using the loop parameter used to determine the hue values. This method will be used during initialization. Make sure the array is full. Let's try to use it. Let's take the same cycle and build a rectangle. As coordinates, we set the current position of the cursor, and the offset calculated using trigonometric formulas. The formulas themselves are not very important. It's just an example to test an array of colors. The color palette works. You can make something amazing out of this. We still need a cycle. We will remove the rest. Let's add another array. It will store our animation objects. The array will be filled in a loop using the push method. Each element added to the array will be an object, an instance of the sprite class. The methods of this class will define the behavior of our animation objects. We have to create this class. But for now, let's remember this line and analyze it later. The last method of the object remains. This is our animation engine. Each animation object will be updated according to the update method of the sprite class. The engine is built on the requestAnimationFrame method. It will allow you to recursively call the original method at regular intervals. And now, let's add a call at the very end of the initialization method. Class is a template for creating objects. So, this is where our creative object ends. Let's declare a class named Sprite. It will have two methods in its body. The first one has a special name, constructor. It's required to initialize class instances. The second method will determine the behavior of these instances. Let's start with the constructor. It takes one parameter. Take a look at the arguments that we used when creating instances of the class. They will become constructor parameters. So, we set the initial values. Location, current and previous. The position of the mouse cursor will be taken as the basis. Figure length, we will work with squares, color, offsets along the corresponding axis. Another additional type of shift. And the last parameter is something like scattering. Now the update method. First, let's build a square in the current coordinates with a given color. Let's check. Good. Now let's add two properties to our creative object. These are arrays to store lifetimes and angles. See what comes of it. After creating the next instance of the class, when moving the mouse cursor, we will add a unit to the array of lives, thereby fixing the beginning of the life of a new instance. In the array of angles, we will add a loop parameter. Let's increase the value of the alpha channel parameter. Back to the update method. We will only draw a square if the lifetime does not exceed 150 units. Accordingly, in this method, the lifetime will increase. Otherwise, using the splice method, we will remove elements with index I from the array of animation objects, the array of angles, and the array of lives. Thus, animation objects will be created, live less than 150 units, move according to the update method, and be deleted. Let's check. So good. Now we need an interesting movement algorithm. And all the magic will happen here. It's only 6 lines of code. There is only one small problem. The formula looks like this. Well, yes. At first glance, it looks complicated. To understand a complex thing, you need to divide it into many simple ones. Decomposition and working with parts. Let's do that. Take a look at the final coordinate calculation for the current square. This is an increment of two types of shift. The second with a weakening coefficient. In these formulas, dx and dy are unknown. They are calculated like this. A certain shift is multiplied by a trigonometric periodic function. The angle in this formula is known, and we will gradually reduce it during the life of the animation object. We calculate the unknown shift using a formula similar to the Pythagorean theorem. But instead of the square root, we use the power of 0.25. To understand this, you need to play with it and try to modify it. And now, let's adjust the size of the square. Let them change throughout life. It looks more interesting now. But I don't see the rotations of those multicolored tails. Let's increase the angle here. And we will wrap the call in the load event, when occurs when the page is loaded. This is a great field for experimentation. Play with coefficients in formulas. Change the number of animation objects. Try to change the time of life. If you like this material, I will be very happy. And on this, lesson came to an end. In the next lesson, I will introduce you to the Web Audio API, and we will build visualizers for your favorite music.